we are still busy with integration. And in this case here, we've got a very interesting question. So they give us find the integral of sine x times cosine x. So this is given here, but they tell us to use different methods. So we want to go and use all the different methods because sometimes a given question could specify that we should solve it using a given method. So with the first one here, they say solve the integral of sine x cos x dx using a double angle formula. But now if I take a look at sine x times cosine x, it doesn't remind me of a double angle formula yet. But what I could do is I could rewrite this in such a way that it represents a double angle formula. So 2 times a half is 1. So now we have 2 sine x times cos x, which in other words could be simplified to as sine of 2x. Now we can use our sine double angle formula. Now that we have this, we can go and find the integral. So now we can say the integral of a half sine 2x dx. And in this case, of course, we can write the half outside. The half is a constant, remember? So I can go and write this. Then if I'm going to integrate sine, please remember that the integral of sine is negative cos. So it is going to become a half times negative cosine of 2x divided by the derivative of the inside, which in this case is 2. And this will give me negative 1 over 4 cosine of 2x plus c. We should not forget, every time when we integrate an indefinite integral, we have to introduce an arbitrary constant. So this we have found here for the integral using a trigonometric identity, in other words, a double angle formula. Now, let's go and take a look at part B, or the method that they specify for part B. They ask us to solve this integral using substitution. So what I'm going to do is I'm going to say let u equals sine of x. They did not say what I should use for my substitution, but I will let u equals sine of x. So du dx is going to be equal to cosine of x. The derivative of sine x is cos x. And if I rearrange this, dx is equal to 1 over cosine x du. Now let's go and rewrite our integral, what we have with our given substitution. So the integral, now since sine of x is u, it becomes u times cosine of x. Now instead of dx, we can replace dx with 1 over cosine of x du. So therefore my integral simplifies to the integral of u du. And if we're going to integrate this, we're going to get a half u squared plus c. But since we use substitution, we have to substitute back in the value for u, which in this case would be a half sine squared of x plus c. So this would be the answer if we had used integration by substitution. Now, for the last part here, they say use integration by parts. Now, this is the interesting part. We have seen in previous videos that I've made about integration by parts. So let's go and explore the following. And this is a very nice one, if I can say so. I'm going to erase this left-hand side here so that we have some space to work, because I want to compare it to what we have found in part B. I do want to keep part B with us. Okay, so let's go and take a look at the following integral. So I'm going to rewrite this. So I'm going to say the integral of sine x times cosine x dx. And now I'm going to use integration by parts. So to use integration by parts, I'm going to say let u equals sine of x and let dv dx equal to cosine of x. Sorry, just ignore that part there. Okay, so du dx is equal to cosine of x. And if I were to integrate this, so dv dx is going to integrate it into sine of x. Remember, the integral of cos x is sine of x. So let's go and rewrite our integral. Okay, so if I rewrite this integral, now I can say, sure, it is going to be u times v, which is going to give me sine squared of x, minus the integral of du dx times v, which is sine of x times cosine of x dx. Now at this stage, you should notice that we are subtracting our original integral. So imagine we have said that the integral of sine of x times cosine of x dx is equal to the following. So I notice that these two integrals are the same. So if it is a subtraction by this integral, I can add it on both sides. So I will get 2 of the integral sine of x times cosine of x dx is equal to sine squared x plus c. Now you will notice that I've introduced my arbitrary constant because technically we have already integrated. Normally with integration by parts, we would integrate the second part as well, and then we will write our plus c. So don't forget the plus c, the arbitrary constant on this side. Now what I can do is I can divide both sides by 2. So therefore, if I divide both sides by 2, I have my original integral sine of x times cosine of x dx is equal to, and in this case here, I have sine squared of x plus c. Remember, c is an arbitrary constant, so c divided by 2 is still the same arbitrary constant. Now, let's compare our answers. So, integration by parts, we have found the following answer. We have found a half sine squared of x plus c. When we have used substitution, we have also found a half sine of x squared plus c. So we do get exactly the same answer. Thank you.